So now we're going to look at an example of a circuit where we're being asked to use superposition to find the current when we have a dependent source. Okay, so again, we're using superposition and we're being asked to find the current I. All right, so the first thing that we want to do is to deactivate the current source. So this would be completely dependent upon the voltage source, 24 volts. All right, you know that a current source becomes an open circuit. So we will redraw the circuit like this. And now we will use KVL around this loop here. And so we have minus 24 plus 3I plus 2I plus another 3I, which is the dependent source. Okay, we put together our like terms. And our I here is going to be 3 amps. Now mind you, that's I prime since it's only due to one of our sources. So now if we want to do only dependent upon our current source, we want to make our voltage source 0, which means it's a short circuit. And this time we leave in this current source. We also leave in the dependent source. We're not making that 0. And we'll look for I again. This time it'll be I double prime. Okay, so for this one we can use node voltage method. And we'll say we have minus I double prime minus 7 amps plus V minus 3I double prime over 2 is going to equal 0. Okay, and so we multiply out by 2. That will give us 2I double prime minus 14 plus V minus 3I double prime equals 0. Putting together my like terms again, minus 5I minus 14 plus V equals 0. Now we know from the circuit that I double prime will be V divided by 3. So we can substitute this in the bottom. So 5 times V over 3 plus V equals 14. Solve that to get V. Okay, and our V is going to be equal 5.25. Okay, and then we know that our I is going to be negative 1.75. Okay, now again we're using superposition, so we need to add I prime plus I double prime. It's going to be 3 plus negative 1.75, which will equal 1.25 amps. Now again, this is our contributions, adding our contributions from our voltage source and our current source and then adding them together to find the total.